Hello viewers. In postgraduate examinations, residents are expected to perform retinoscopy and write a prescription for a given case. We have already discussed how to perform retinoscopy. Today we shall discuss how to write the corresponding prescription. The only history required, unless some other major finding is discovered, is the name, age and drug used for dilating the pupil. After performing the retinoscopy, note down the values obtained for neutralization in both horizontal and vertical meridians on a power cross. For today's discussion, we shall assume the principal meridians are at 90 and 180 degrees. The next step is the distance correction. Again, for simplicity's sake, we shall assume retinoscopy was performed at 1 meter distance. We learnt in a previous session that the correction for this is 1 diopter. So, subtracting 1 diopter, we get for the vertical meridian plus 2.5 minus plus 1, which is equal to plus 1.5. And in the horizontal meridian, we get plus 3.5 minus plus 1, that is equal to plus 2.5. Next is the correction for the inherent normal ciliary tone, which has been abolished by the cycloplegic. For cyclopentolate, the correction is plus 0.75 diopters, which should be subtracted from the distance correction. So now in the vertical meridian, we get plus 1.5 minus plus 0.75, which is equal to plus 0.75. And in the horizontal meridian, we get plus 2.5 minus plus 0.75, which is equal to plus 1.75. So this is the actual refractive error that needs to be converted to a prescription. To write the prescription, generally the meridian value which is numerically smaller is chosen, even though this is not mandatory, and if you choose the other meridian first, you just get a transposed form. So here we should take the smaller number, that is plus 0.75. This is the sphere. To get the value of the cylinder, we need to understand that the lens has a refractive value of plus 0.75 all around, including the horizontal meridian. Only in the horizontal meridian, we want a power of plus 1.75 diopter. So we need to add the difference of the two values to the horizontal meridian. What is the difference of the two values here? Subtract the value of the sphere from the value in the horizontal meridian. So here we get plus 1.75 minus plus 0.75, which is equal to plus 1. That is the value of the cylinder, and we shall write this here. What about the axis? We want this plus 1 diopter power to be in the horizontal meridian. Since in cylindrical lenses the power is perpendicular to its axis, we write axis 90 so that the effective power is at 180. The vision with this power is written next, and lastly the diagnosis is written. In this case, the diagnosis is a compound hypermetropic with the rule astigmatism. Now we spoke of drug correction. This is a little bit of a debatable issue, as there are different points of view regarding how much correction must be given for a particular drug or whether drug correction needs to be given at all. So I will lay out a middle path here for general guidelines. You would do well to adapt to whatever is followed in your institution. Atropine is the strongest cycloplegic, and hence 1 diopter is subtracted for ciliary tone. It is 0.75 for cyclopentolate, 0.5 for hometropine and tropicamide, though many people do not prefer to give any correction for tropicamide. Some situations where correction for the cycloplegic should be avoided are myopia and myopic astigmatism, to avoid over minus prescription. Aphakia and pseudophakia, as there is no accommodation and hence drug correction is not relevant, and presbyopia, as the decreasing ciliary tone is variable and inconsistent. Let's take another example. Patient here is a 45-year-old and the drug used is phenylephrine. These are the retinoscopy values. After distance correction in the vertical meridian, we get plus 0.5 minus 1, which is equal to minus 0.5. And in the horizontal meridian, we get minus 1 minus plus 1, which is equal to minus 1 minus 1, which is equal to minus 2. And correction for the drug is not required here, as phenylephrine has no cycloplegic action, and also patient is a presbyope. So to write the prescription, the numerically smaller value is minus 0.5, so we shall take that as the sphere. To get cylinder from the other value, subtract the sphere. So minus 2 minus of minus 0.5, which is equal to minus 2 plus 0.5, which is equal to minus 1.5. We want this extra power in the horizontal meridian, so we shall place the axis at 90 and we shall write down the vision here. Now, since the patient is 45 years old, we need to write a near add. For the refraction case, an age-wise approximation may be made in accordance with the following. So, since this patient is 45 years old, we shall add plus 1.5 diopters, and this value should be added to the sphere alone. So, here it will be minus 0.5 plus 1.5, which is equal to plus 1. The cylinder and axis should be copied down without any change. Here we shall write the vision for this power, and the diagnosis is a compound myopic against the rule astigmatism with presbyopia. One last example. If you get a final value like this for prescription, you may take either value as the sphere. So if you take minus 0.5 as the sphere, this is what you get. And if you take plus 0.5 as the sphere, this is what you get. The second may be more preferable as it is in the minus cylinder form, which is more acceptable to the patient. So that's it for today. If you like what you saw, subscribe to my channel and hit the bell icon to never miss an update from AP's Ophthalmology Pulse. You may watch my other videos by clicking on the thumbnails. Please leave a note in the comment section if you wish for any particular topic to be covered in future. Look forward to regular updates. Thank you for watching.